amazing, like a transparent plastic. Do you see guys what are them?
Oh, actually this one is a plastic wrap. We normally use is to wrap food like that.
This thing looks elastic.
Yeah.
Is it the egg can go inside here? Go inside the bowl?
Oh, actually, this one is the plastic wrap. The egg cannot enter this one. But I will tell the detail about the plastic wrap to yours. Yeah. Okay, good morning. My name is Bmfb. Today I will discuss about plastic wrap. Okay, what is plastic wrap? Plastic wrap is basically a thin plastic film. It is used to seal food so that our food will stay last longer, and also to prevent from any other things such as microorganisms, insects and other stuff like dust to entering the food. The dimension is for the plastic wrap is 12.7 micrometer thickness, and the width is 0.5 meter. That's all. For the plastic wrap, basically we have three material to use to produce the plastic wrap. This is PVC, LDPE, and LLDPE. Before we create a plastic wrap, we must have a material selection strategy. First, we will create a design requirement. First, we must know the function. What is the function of the plastic wrap? As we know, the function of plastic wrap is to wrap food. For the constraint, it consists of 5 criteria, which it must have transparent, flexible, heat resistant, tear and puncture resistant, and lastly, it must be thin. Then, for the objective, I create 3 objectives, which first of all, we must minimize the cost in producing the plastic wrap, and second one is we must maximize the performance in the plastic wrap, and lastly, the plastic wrap that we produce must be safe to use by the consumer. And the 3 variables consist of 2. First is choice of material, and last is choice of process. After that, we will do the screening. Here is the table for the screening, which is for PVC, LDPE and LLDPE. And this one is the design requirement for each of the material. So basically, these are data I obtained it from CES and also MedWeb. Okay, for the matrix selection, we will calculate the average based on the first table. So all data already calculated for the average. And then after that is the last one is ranking. Ranking, as we all know, based on the calculation, PVC is on the first place, and second one is LDPE, and last one is LDPE. But PVC, due to health concern, we eliminate it because it contains plasticizer such as DH. So we use LDPE and LLDPE. That's all. Thank you.
Hello, good morning. My name is Siti Nurul Sharif. My part is translation for process selection plastic wrap. Okay, function, shaping process, constraint, thermoplastic, flat shape, thickness roughly, and smooth surface. Objective is to minimize the cost, and free variable, choice of process and process operating conditions. This is screening the list of manufacturing process for making plastic wrap. This table is based on the graph attribute, and we summarize the graph, and we use the injection molding instruction because it passes all the criteria. ranking, we use conventional machining that uses tools such as lathe, milling machine, boring machines, drill presses or others with a sharp cutting tool to remove material to achieve the desired geometry. And usually there is a direct contact between the tool and raw material. For rotational molding, there's a high temperature, low pressure plastic forming process that uses heat and rotation to produce hollow and one-piece parts. Okay, extraction its ability to create very complex cross section and to work material that's brittle because the material only encountered compressive and shear stresses, and it also form parts with an excellent surface finish. Why choose extraction process to produce plastic film? Because it high speed, high volume production and low cost, relatively cheap other than other process. Why did we eliminate both of the processes? Conventional machining process because it's so high cost of CNC machine time, relative high cost of lot plastic material and high volume or swath to be removed and present difficulties. And the last, rotational molding process because it's a high cost of raw material, high cycle times and limited material options. Okay, that's all. Thank you.
Okay, I'm Hagilan. Today I'm going to explain about non-metallic process for the plastic film. So we have chosen blown film extrusion. So this is a conventional blown film extrusion process machine. So let's focus on what raw materials we can use by this machine. So actually we are focusing for LLDPE, that means linear low density polyethylene and low density polyethylene. So we are also focusing on PVC, but in this case we are avoiding PVC for it's quite expensive and it have long process. So for food packaging we are focusing for low linear density PE or LDPE. So these are actually derived from ethylene process or methane process, which is produced by natural gases and petroleum. So polyethylene is made directly from ethylene. So because of we are avoiding PVC is vinyl chloride, which quite chemical conversion inside, and then acetylene will produce some gases. So that's why we avoid food packaging by using PVC. Next is I will explain the process. This is the example of the machine. So this is the winding unit. So the polymer plastic LDPE will wind here and will step up to the up and it will be wrapped here somewhere here. So I will detail explain in the next page. So the first is the granules of plastic are heated until because we are focusing for PE 100 degrees Celsius. So they will be heated at 100 degrees Celsius here. And then the molten polymer is forced through the die to form a tube, warm and stretchable. So it will be forced to the die, so it will be formed like a tube. And then the tube is then compressed air blown is inside the moving tube from large bubbles. So it's making a large bubble to stretch the thing to make a plastic film. And then the bubble stretches into the desired thickness. And when the desired thickness is observed, so the bubble will close on the rollers and then it will be rotated. So the film is rolled onto a large metal rod and holds several kilometers. So this process is actually will produce a big and long kind of film, and then this film is cutted and wounded to again wounded to small rollers, and then the last part this process will be continue for the rolling process, and then again because it's produced sealing means it's make that thing is more strong compared to the normal one. So actually the rolling process will be end up with the wrapping process, where the thing will be rolled into paper roll, and the paper roll will be packed into the box. The box will have a shader so that thing can cut and easily can use for the packing process. So next, there is a video to present this process. So
Okay, good morning everyone. My name is Goginesh Balu. So I am here to explain about the present about the effect of the parameters on plastic wrap of food. So mainly is plastic wrap a good insulator? We all have that kind of question. So no, plastic wrap does not have any very qualities that make it a good insulator. So it may slightly exist in heat at instant, but aluminum foil is better insulator for the suggestions. And then can plastic wrap be used to freeze food? Yes, plastic wrap will protect food when in the freezer. It is recommended that no air is between the plastic wrap and the food. So there is no any bacteria growth among the food and the plastic wrap. So it will protect the food from the freezer burn. Can industrial plastic wrap be used with consumable products? Industrial plastic wrap such as pellet stretch film should not be used in direct contact with consumable products. Next is can plastic wrap be heated? Standard food plastic wrap should not be heated in the oven with form of direct heat, because when the direct heat is on the food, it will spoil the condition of the food. So untreated plastic wrap can release chemicals and melt when heated plastic wrap tissue. These are the example of plastic wraps that we have at the market nowadays. So the final question is, can plastic wrap used in the oven? Plastic wrap is not suitable for conventional oven because the heat is too much. So stoves or toaster ovens such as bread toaster, such as like that, the plastic will wrap if used these ovens. Okay, I would like to end my presentation, but before that I have a video to present.
My name is Himi Singh, and I would like to tell you how nowadays how they are going to test and maintain the quality of the plastic wrap. So to test the plastic wrap, we have a few tests. One of them is the falling dart impact test machine, and another one is the test of permeability to liquid and gas. For the falling dart impact testing machine, the test specimen is clamped securely in a pneumatic ring. So you can see this is the pneumatic ring of the machine. The mounting bracket is adjusted to the appropriate drop height. This is the mounting bracket, and the dart is inserted into the bracket. You can see this is the dart. This is the dart. The dart has a hemispherical head, and the weight is added each time for each test. The dart is released to drop onto the center of the test specimens. If the test specimens pass, the drop weight will increase by 1 unit. So the weight will increase by 1 unit. If the test specimen is failed, the drop weight will decrease by 1 unit. This is the video for this test. For the second test, the test of permeability to liquid and gases. So for the first one is the water vapor, for the water permeability to liquid, and the second, this one is for the permeability to gas, for the permeability to liquid. Water vapor permeability is measured by filling a dish with calcium chloride. We know that calcium chloride is very attractive to water. It can absorb water vapor. Is a highly water absorbent substance. It is covered with a sample of plastic wrap and is weak weight. The dish is then placed in a chamber with a controlled temperature and humidity. After a measured amount of time, the dish is weighed again. The increase in weight shows how much water vapor has passed through the plastic. And then for the second test, the gas permeability. The gas permeability is measured by placing a sample of plastic wrap between two chambers. The upper chamber contains a pressure of 100 kilopascal, and the lower chamber contains a vacuum connected to a tube containing liquid mercury. The liquid mercury is very sensitive to pressure. As the air in the upper chamber passes through the plastic wrap, it increases the pressure in the lower chamber and forces the level of mercury to drop. The change in the level reveals how much air has penetrated through the plastic wrap. And then for the defects, the common defects in the plastic wrap, due to the gel defect, this is the gel defect that looks like the eye of fish. This looks like the eye of fish, and there are the result of small unmelted resin particle. This is actually happens because the gel doesn't melt very well in the extrusion, and this causes the defects on the surface of the plastic wrap. So gels are the high molecular weight polymer particles that do not melt during the processing. It may soften and elongate, but it doesn't really melt because it has high molecular weight. After passing through the screen, they snap back or return to their original shape, forming small hard particles in the melt. This is what happens when they come out. So there are two ways to overcome this defect. The first one is to avoid the overspeed of extrusion. Means we need to use appropriate shape to extrude the appropriate speed to extrude the plastic film from the extrusion, and we need to increase the plastic melt temperature in the extrusion chamber. And for the conclusion, the material that we use is LDPE, and the process that we use is extrusion process. That's all. Thank you.
Oh yes, the 4 left already. I'm the only one going to finish this alone. Thank you.